Hello students, here is the question. We have given some hydrocarbons and they have asked you about the correct order of acidic strength of hydrocarbons. Okay, acidic strength means acid is the one which give H plus ions. Let us look at hydrocarbons. The first hydrocarbon is HC triple bond CH. Second one is CH2 double bond CH2. Third one is tertiary carbon type of alkane, or it is isobutane. Next, CH3 CH2 CH2H. Okay, if they are showing the acidic property, what you have to consider? You have to consider the stability of the conjugate base. That means if this loses hydrogen H plus, then what is the, this is acetylide ion. Next, when it loses the H plus, it is ethanide ion. You have to look over the stabilities of these ions. Now, if this loses H plus, then tertiary butyl carbanion is being formed. Next, if you look at this one, then it is propanyl carbanion. Now, here how the negative charge stability can be assessed? Decrease in the negative charge increases the stability. That means you have to look over the hybridization correspondent to the carbon atom. Here, this is sp hybridized, this is sp2 hybridized, these two are sp3 hybridized. Then whichever is having more s character, it is more electron negative. Then if it is more electron negative, then automatically there will be a decrease in the negative charge. Therefore, this is most stable. That is acetylide ion. First one is most stable. Therefore, the first one will be most acidic. Next, this is having 33.3% S character. Therefore, it also decreases when compared to this sp hybridized. Therefore, this is also these two. These are having the negative charge on the carbon on the sp3 carbon atom. Therefore, these two are having 25% S character, 25% S character. Now, between these two, these are carbanions. Then we will look into the stabilities. This is tertiary carbanion, this is primary carbanion, this one. This gives tertiary carbanion, this gives primary carbanion. Then automatically here donor groups are there, more the donor groups, less the stability. Therefore, this is less stable. Now, arrange the acidic strength. 1, it is most acidic, then 2, then 4, then 3. Between 3 and 4, that is propyl carbanion is more stable than the tertiary carbanion. Okay, this is about this question. Next question, that is 17th question, what they have given. In chromatographic techniques, which are the following follows preferential adsorption? Now, I briefly explain about the chromatography. What is chromatography? It is method of separating the liquids in the liquid mixture on the stationary phase by means of mobile phase is called as a chromatography. There are two techniques that is being applied, and the famous one is adsorption technique. Okay, what is the question is, In the chromatographic techniques, which of the following follows preferential adsorption? Straight, easiest question. The first one, column chromatography. Next, thin layer chromatography. They have given 3 techniques. One is column chromatography, and second one is the thin layer chromatography, TLC chromatography, and third one is paper chromatography. Of these techniques, the first 2, column chromatography and thin layer chromatography, they are based on adsorption technique, because here in the column chromatography there is a burette is being taken, in that a cotton wool is placed and the sand is poured into that column and adsorbent is placed, and at the adsorbent, that is adsorbent means alumina, generally they take alumina, on that liquid mixture is placed which adsorbs on that alumina, and when a solvent is poured, depending on the extent of adsorption, the liquid mixture separates out. Same technique, but thin layer chromatography is a different one. Solvent is placed in the beaker and a adsorbent which is in the rectangular strip is taken and it is placed in the solvent. Then automatically, depending on the retardant factor, that is solvent creeps up to the thin layer and it separates the liquid mixture which is being placed in it. Okay? Both A and B depends on the adsorption. Now what they have given, A only, like that the options are being given. A only, next B only, and third one C only, and A and B both. So the option, fourth one is the correct option, isn't it? Next, consider the following sequence of reactions. Okay, they have given 3 reactions here. Probably whenever students observe it, this is a big molecule is being given. On one side it is the ester and another side aldehyde is. Then it is being converted into the dicarbonyl compound by means of the A reagent, and later on by means of B reagent it is being further decreases its area, and this is being if you observe, probably you might have got a knowledge over these reactions. Next one, the C. Now you have to judge the 3 reagents. Okay, this is OH, and now look over this reaction. On the first reaction, this is ester, isn't it? This is an ester. This is being converted to aldehyde by means of which reducing agent converts the ester into aldehyde. That is the first question. Next, after the, you can easily recognize this one because the 2 aldehydes are there. On the adjacent carbon atom there is alpha hydrogens, therefore it undergo aldol condensation. Okay, intramolecular aldol condensation, therefore it is being condensed here. Next, this CHO is converted to the alkane. Then the first one, that is a reducing agent, which is especially it is having a significance. that ester converted to aldehyde. Generally, lithium aluminum hydride, what it will do, it will convert the ester into alcohol. But here, ester converted to aldehyde is the only reducing agent. The only reducing agent is dibal H, diisobutyl aluminum hydride. Okay. Next, what is the second one? Since as I have mentioned, these are alpha hydrogens, therefore this is being condensed here. The CH2, it will be condensed and you will get a double bond here. The so that is there in the third compound. Therefore, this is B is NaOH. Now CHO converted to CH3. Now there is a specificity here. You can condense it, you can convert it into hydrocarbon by means of the two specific reduction processes. One is Clemmensen reduction and other one is the Wolff-Kishner reduction. Then here in the alcoholic group is there. Alcohol is very sensitive to the most reactive metals. Therefore, Clemmensen reduction cannot, it can reduce OH also, it can react OH also, it is very sensitive to this zinc. Therefore, it cannot be used. Then which can be used? Then it is Wolff-Kishner reducing agent, that is, it takes Wolff-Kishner reduction takes place in two steps. One is with hydrazine and the hydrolysis. Okay. Therefore, what are A, B, C? A is a dibal H which converts ester into aldehyde, and B is intramolecular condensation that takes place in the presence of the base, and the hydrazine in the presence of KOH that can be converted to alkane. Okay, next question, that is 19th one. What a simple question it is. The correct statements about the metals are being given. Which metals? Correct statements about zinc, cadmium and hydrargyrum. Okay, where they are present? They are D block elements. They are present in the 12th group. Therefore, zinc, cadmium, hydrargyrum are 12th group elements of D block. They belong to the D block. The statements are, you look over the statements, all are solids at room temperature. Okay. Now you will get a doubt, isn't it? At room temperature, which are solids, you might have remembered it. Then they have high enthalpy of atomization. Delta H atomization is high. Okay. Next, third one. All are paramagnetic. All are paramagnetic. That is 3 statements. What is the question? Correct statement. The 4th one. Zinc cadmium cannot show variable oxidation state. Okay. Whereas mercury can show. Okay, these are the 4 statements. Then which statement is the first statement? You look at it, then you will get a doubt, isn't it? Because you know that zinc, cadmium, they are metals, they are solids. Mercury is also metal, but mercury, it is existing in the liquid state. Therefore, first statement is incorrect. What about the second one? Delta H atomization is very high for these metals. How can it be? When you move from left to right, what happens to the atomic size? it first decreases and remains constant and then increases. For the 12th group, they are having more atomic sizes. Then the metallic bond strength is less. Therefore, enthalpy of atomization is very low when compared to the next previous group element, that is 11th group. Therefore, enthalpy of atomization is high is a wrong option. Okay? Then all are paramagnetic. How can it be? Because all are having D10 configuration and also NS2. NS2, N-1 D10 configuration is there. Therefore, all are diamagnetic here. Therefore, 3 statements are wrong. Then what you do? Then automatically 4th is the correct option. Okay, look over it. Zinc, cadmium, as their sizes are very less, therefore automatically they cannot show the variable oxidation state, even though cadmium possesses vacant d orbitals. Okay, but mercury can show, because as we move down the group, that you can mercury can show the mercurous and mercury cation. Okay, therefore this 4th statement is the correct option. They have given an equation. You can easily recognize this is a famous equation. Okay, here is phenol on reacting with chloroform. Okay, they have given sodium hydroxide and the acid medium. Then major product. Okay, major product. Then what is the IUPAC name of the product? IUPAC name of the product. Now, if you look at the reaction, what is that reaction? If you remember, that is a famous reaction in phenols, that is Reimer-Tiemann reaction. In that, what is the electrophile? That is dichlorocarbene is the electrophile. Then dichlorocarbene, it is attacks the ortho position of the phenol, and then when it undergo hydrolysis, it gives the 2-hydroxy benzaldehyde. What is the IUPAC name of this one? This is ortho-hydroxy benzaldehyde, or it is also called as orthosalicylate, but IUPAC name is 2-hydroxy benzaldehyde. Okay. This is about the option. There are different options are being given. The first option is 2-hydroxy benzaldehyde. Second option is 2-hydroxy benzoic acid. Third option is 4-hydroxy benzaldehyde, and fourth option is 3-hydroxy benzaldehyde. Automatically it is at the ortho position, that is major product is 2-hydroxy benzaldehyde. Numerical value type questions. The first one is integer type of questions. That once again I repeat. Now we are going to integer type of questions. The first question, that is 21st question, that is being given. What is the oxidation state of iron in the complex in brown ring test? Okay, iron oxidation state in brown ring test. There won't be any options here. What is brown ring test and what for it is being used? Brown ring test is especially used to identify nitrate ions, isn't it? Okay, in the conformation of nitrate ion, brown ring test is being used. How it is being done? It can be done, we take salt, nitrate salt, and we add freshly prepared FeSO4 and we place it in a slant position, and then concentrated H2SO4 is added dropwise. Okay, dropwise. Then you will see a brown ring at the junction of the two solutions. What is the formula of the brown ring? This is the formula. FeH2O taken 5 times, NO plus, nitrate ion changes to NO plus, NO plus, it is having oxidation state of +1, that is group oxidation state. Now you calculate the iron oxidation state. X plus 0 plus 1 minus 2 is equal to 0. X is equal to what you get? The +1. Therefore, +1 is the oxidation state. Okay. Therefore, integer answer is 1. Next one is also a very easy one. How many of the following compounds have 0 dipole? In a very session, there is a question regarding to the dipole moment, whether it is polar molecule or non-polar molecule. 0 dipole moment, not equal to 0 dipole moment, which is not having 0 dipole moment. Such type of questions are being asked. Now, what are the number of compounds having 0 dipole moment? The compounds the students memorized are NH3, H2O, HF, CO2, SO2, BF3 and CH4. Okay. Here NH3, it is a pyramidal molecule, it possesses dipole moment. Therefore, mu is not equal to 0 here. H2O, it is an angular molecule. Therefore, mu is not equal to 0. HF, there is an electronegative difference. Therefore, mu is not equal to 0. Next, CO2. CO2 is perfect non-polar molecule because it is a linear molecule. Dipole moment or bond moment cancel with each other. Therefore, mu is equal to 0. SO2 again angular molecule and dipole moment is not equal to 0. Therefore, it is a polar molecule. Boron trifluoride, it is a triagonal planar molecule. Mu is equal to 0. Next, CH4. CH4, it is a tetrahedral and the perfect molecule, regular molecule, mu is equal to 0. Now, here CO2 and boron trifluoride, CH4. These three are having 0 dipole moment. Therefore, number of compounds having 0 dipole moment is 3. Next question is, calculate equilibrium constant for the given following reaction. Okay, the reaction is N2 plus 3H2 gives rise to 2NH into 10 to the power of minus 2 whole square. What is the nitrogen concentration? 2 into 10 to the power of minus 2. Next, that is 3 into 10 to the power of minus 2 whole cube. Okay. Then if you calculate, because it already we have done, that is we will get 416.7. It will be nearly equal to 470. Next question is, 50 ml of 0.2 m oxalic acid is completely neutralized by 25 ml of NaOH solution. Okay? Find the amount of NaOH present in 25 ml of the given NaOH. What is the question? First of all, you think about it. It is based on acid-base titration. Okay? 50 ml of 0.5 m oxalic acid. What is the formula of oxalic acid? H2C2O4. It is being titrated with NaOH. you write the data, because when it is being completely neutralized, number of equivalents of acid is equal to number of equivalents of base. Even though they have given in molarity, you convert it into normality. Okay? Number of equivalents of acid is equal to number of equivalents of base at end point of the titration. From that, you calculate the normality of NaOH. After finding out the normality, you calculate the weight of NaOH or mass of NaOH in 25 ml. Okay? Now we will do. That is H2C2O4. What is the volume of acid? That is given as 50 ml. And what is the normality of the acid? Molarity into N factor. What is the molarity? 0.5 into N factor, that is H2C2O4. Therefore, basicity is 2. Therefore, 0.5 into 2, that is 1. What about volume of the base? They have given 25. And normality of the base, you have to find out. Okay? Now, VA-NA is equal to VB-NB. Number of equivalents of acid is equal to number of equivalents of base. Number of equivalents, you can calculate volume in liters into normality. This is number of milli equivalents. We have taken number of milli equivalents of acid here and as well as base. Then 50 into 1 is equals to 25 into normality of the base. Then we can calculate normality of the base, that is 50 into 1 by 25. How much it is? It is 2. Normality we got. Then what is the mass of NaOH or weight of NaOH or amount of NaOH? Weight of NaOH, how can you calculate? Volume in liters into normality into gram equivalent weight. Okay? Then what is the volume in liters? It is 25 ml only. Therefore, 25 into 25 by 1000, we get volume in liters into what is the normality of the solution. Just now we have calculated as 2, and what is the gram equivalent weight? 40. Okay? Then you calculate it. Then what you get? You will get 2 grams. 2 is the answer. Next question is, standard enthalpy of vaporization of CCl4 is 30.5 kilojoules per mole. Okay? Enthalpy of vaporization of CCl4 is given. CCl4, okay, per mole, that is 30.5 kilojoules per mole. Find the heat absorbed. Carefully listen. Find the heat absorbed for vaporization of 294 grams of CCl4. Okay? They have given for 1 mole and you are asked to calculate for the 294 moles. Then what you do? What is the concept of enthalpy of vaporization? The amount of heat that is required to convert the 1 mole of CCl4 liquid into 1 mole of CCl4 vapor at its boiling point. It is called as enthalpy of vaporization. That is 1 mole. For 1 mole, whatever the enthalpy of vaporization that is being given, for 1 mole, what is the heat that is being required? 30.5 kilojoules. Then for heat absorbed for the vaporization of 294 grams, then you calculate number of moles of CCl4 given, then it is given mass by molar mass. What is the given mass? 294. What is the molar mass? Here 154 is the molar mass. Then you will get 1.909, that is 1.91 is the number of moles. For 1 mole 30.5 kilojoules, then for 1.91 moles, how much? That is, how much it is? 30.5 into 1.91. How much it is? It will be 58.255 kilojoules. Next question. Find the molality of 0.8 m H2SO4. Molality of 0.8 molar H2SO4. Carefully listen. Density is equal to 1.02 gram per ml. Okay. It is also simple formula based question. If you know the concept, then you go through the concept, or if you know the formula, then you go through the formula. Okay, whichever it is. Now molarity is given. What is the molarity of this H2SO4? 0.8 molar. What is the density that is being given? It is 1.02 grams per ml. Okay, then what is the molality? Molality is being calculated as simple number of moles of the solute, which is equal to the molality. Therefore, molality by what is the weight of solution solvent in kilograms. First, you calculate the weight of solvent first. What is the weight of solution? Since molarity is being given, then automatically the volume of the solution will be 1 liter. That means 1000 ml. 1000 into 1.02. We will get the mass of solution minus this m gives the number of moles, isn't it? Okay, well, this is density. Okay, D is the density. Then molarity gives the number of moles. Molarity into molar mass of the H2SO4 gives the weight of H2SO4 or mass of H2SO4. Therefore, molarity into gram molar mass. This will be in grams. Therefore, you divide it in by means of 1000. What is molarity? It is 0.8 by 1000 into 1.02 minus what is the molarity? 0.8 into 98 by 1000. Okay? Then you calculate it. That is 0.8 into 1000. It will come as 800. 1020 minus 0.8 into 8 8 is 64. 8 9 is 72, 78.4. If you subtract 1020 or if you subtract this one with 1020, you will get the 941.6 and you will get the 0.849. Okay, nearest integer is 1. Therefore, 1 is the answer for this one. Next question. Aqueous solution of AuCl4 minus, okay, this is AuCl4 minus aqueous solution is electrolyzed by passing current for 10 minutes. Okay, this is Au oxidation state. In this one is +3. Okay, and we passed the current for 10 minutes. The mass of gold Au deposited at the cathode is 1.97 grams. Okay, atomic mass of this one will be 197, and you are asked to find out the current. Then you can use the formula to find out the current. Small m is equal to MIT by ZF. You can use this formula. I is equal to mass into Z. Z is the oxidation state. This is equal to Z. F is Faraday, 96,500 coulombs. Okay, MZF by M into T. You substitute the things. 1.97 into 3 into 96,500 by what is the atomic mass of it? It is 197. 10 minutes they have given. Time is 10 minutes. 10 into 60, that is 600. Okay? If this is being calculated, you will get 4.825 amperes. This is equal to 5 amperes. Nearest integer is 5 amperes. If half-life of this, next question, half-life of the radioactive bromine, that is bromine 82, okay, half-life is given as 36 hours. Find the percentage remaining after 1 day. To the nearest integer you have to. That is the time period that is being given, 36 hours. Sorry, not 36 hours. Total time period that is given is 24 hours, that is 1 day. And what is the T half that is being given? 36 hours. Okay? Half life is 36 hours. And what is, how to find out the percentage of bromine 82 remaining? Okay? It will be calculated as 1 by 2 to the power of n into 100. What is n is? Number of half-lives. Number of half-lives. How it can be done? The total time period, total time by the T half. And what is n now? 24 by 36. What you get? 2 by 3. Therefore, 1 by 2 to the power of 2 by 3 into 100. It will come as 1.589. Therefore, 100 by 1.589 it will come. Okay, 2 to the power of 2 by 3, you can write it as, if you apply logarithm 2 by 3 log 2 value is 0.3, 2 by 3 into 0.3. Okay, it will be 0.2, anti-logarithm value is 1.589. Then 100 by 1.589, it will be 62.89. That is 63% remains after 24 hours.